Tonight, as you close your eyes and slowly drift into sleep, something extraordinary is already unfolding. Something vast, mysterious, and happening right now. Not here, not in your room, not even on this planet, but across the vast spiral of the Milky Way. While your breathing softens, while your thoughts begin to loosen and fade, while everything around you grows quieter and more distant, the galaxy does not slow down. It does not pause. It never has, and it never will. Right now, at this exact moment, you are moving. Even as you lie completely still, you are spinning with the Earth, carried through space at speeds so great they almost feel unreal, orbiting a star that itself is drifting through a galaxy, and you don't feel any of it. There is no wind, no sound, no sense of motion, and yet you are traveling faster than you ever have in your life. Somewhere far beyond the edges of your night sky, new stars are quietly forming inside vast clouds of gas and dust. Elsewhere, ancient stars, older than entire civilizations, are reaching the ends of their lives, fading slowly or collapsing into something far more mysterious. Invisible forces are pulling on everything, guiding motion, shaping paths, holding entire systems together without ever being seen. And between all of this, light is traveling endlessly, crossing distances so vast that what you see in the sky tonight is not the present, but the past. Some of that light began its journey long before you were born, some of it before humanity even existed, and still it arrives, quietly, patiently, without ever announcing itself. The Milky Way is not chaotic in the way you might expect. It does not feel rushed. It does not feel loud. It moves with a kind of calm, almost like a slow, steady breath, stretching across billions of stars. And tonight, as your body begins to relax, as your muscles soften, as your thoughts drift further and further away, you are still part of that motion. You always have been, because even in your deepest sleep, you are not separate from the universe. You are inside it, carried by it, moving with it. So instead of holding on to the noise of the day or the weight of what comes next, just let it all fade. There is nothing you need to do, nowhere you need to go, only this quiet moment and the vast, silent motion of everything around you. And as you continue to drift, we'll gently begin to notice what is already happening all around you, inside the Milky Way. You may not feel it, but beneath you, the Earth is already in motion. Slowly, steadily it turns, carrying oceans, continents, cities, and you through the darkness of space. The night around you feels still, calm, almost frozen. But that stillness is only an illusion, because even now, you are being carried across the surface of a rotating world at a speed of over 1,000 kilometers per hour. And yet, there is no sensation of movement, no shift, no vibration, only quiet. Above you, the sky appears unchanged. The stars seem fixed in place, as if they've always been there, watching. But they are not fixed. They are not even close. Every single point of light is moving, some drifting slowly through the galaxy, others orbiting unseen centers, all of them part of a vast, continuous flow. And as the Earth turns, your position beneath that sky changes too. Without noticing, you are facing different stars, different regions of the Milky Way, different fragments of an enormous living structure. If you could step outside for just a moment and watch the night carefully, you would see it. The slow shift, the quiet rotation of the sky, time made visible. But from here, lying still, wrapped in silence, it feels as though nothing is happening at all. And that is what makes it so easy to forget, that this quiet moment is filled with motion. The Earth continues its journey around the Sun, a path it has followed for billions of years, a gentle orbit, so familiar, so consistent, that it feels permanent. But even this is only part of something much larger, because the Sun itself is not standing still. It is moving, carrying the entire solar system with it through the Milky Way. Every planet, every moon, every asteroid, every quiet night like this one, all of it traveling together through the galaxy. And the path it follows is vast beyond imagination, a slow orbit around a center of the Milky Way, taking hundreds of millions of years to complete just once. Which means that every moment of your life, every breath, every memory, has happened while you were gently circling the heart of a galaxy. And still, you never feel it. No rush, no pull, only stillness, only rest, as if the universe itself has softened just enough to let you sleep. And yet, far beyond this quiet orbit, other things are happening, things much larger, much older, much distant. The Milky Way itself is turning, not quickly, not violently, but slowly, like a vast, silent spiral unfolding across space. Billions of stars moving together, held in place by gravity, each following its own path and yet part of something greater. And somewhere within that immense structure is this small, quiet corner where you lie at rest, unaware of the immense journey you are on. For now, there is nothing you need to follow, nothing you need to track, just the gentle understanding that even in stillness, you are moving. And as that thought slowly fades, we can begin to drift a little further outward, away from Earth, away from the familiar, and closer to the quiet, unfolding motion of the galaxy itself. The movement of the galaxy is not something that happens all at once. It is not a single rotation, like a wheel turning in place. It is layered, structured, each part moving at its own speed, along its own path. And the deeper you look into it, the more complex it becomes. The Milky Way is a spiral galaxy. Not a perfect spiral, not symmetrical, not uniform, but a vast, stretched system of arms made of stars, gas, dust, and invisible mass. These spiral arms are not solid structures. They are not fixed lanes where stars sit permanently. They are regions of higher density, like slow-moving traffic in a city. Stars enter them, move through them, and eventually drift out again, which means that the Sun itself and everything orbiting it is currently passing through one of these arms, a region known as the Orion Arm, a relatively small segment of the galaxy, positioned between two much larger spiral arms. From this location, we are not at the center. We are not at the edge either. We exist somewhere in between, about 27,000 light-years away from the galactic core. That number is difficult to visualize. Light itself, moving faster than anything else in the universe, would take 27,000 years to reach the center from where we are. And yet, within the scale of the Milky Way, this is considered a middle position. The galaxy spans over 100,000 light-years across, possibly more. And within that space, there are between 100 and 400 billion stars, each one with its own story, its own motion, its own system of planets, debris, and radiation. And none of them are standing still. Stars closer to the center of the galaxy move faster. They complete orbits in less time. Stars farther out move more slowly. This creates a differential rotation, where different regions of the galaxy are constantly shifting relative to one another. If the Milky Way rotated like a solid object, its spiral arms would wind tightly and disappear over time. But they don't, because the galaxy is not rigid. It behaves more like a fluid system, guided by gravity, but never locked into place. The Sun, for example, travels at roughly 828,000 kilometers per hour around the galactic center. At that speed, it still takes about 225 to 250 million years to complete a single orbit, one full trip around the galaxy. This is sometimes called a galactic year. And by that measure, since its formation, the Sun has completed only about 20 to 25 orbits. That is the entire history of the solar system, measured in galactic motion. While you sleep tonight, the Sun continues along that path, moving silently, without any sign of effort, carrying everything with it. The planets remain bound by gravity, each following its own orbit around the Sun, while together they follow a much larger orbit around the galaxy. It is motion within motion, a system nested inside another system, each layer operating on its own scale of time and distance. If you could observe this from far outside the Milky Way, you would not see chaos. You would see structure, a slow, organized rotation, with arms extending outward like currents in water. But even that image would be incomplete, because much of the galaxy cannot be seen. Between the stars, within the arms, and surrounding the entire structure, there is something else, something that does not emit light, does not reflect it, does not interact in ways we can easily detect. Dark matter. It makes up the majority of the galaxy's mass, and without it, the Milky Way would not hold together. Stars at the outer edges would move too fast and drift away into intergalactic space. But they don't. They remain bound, which means something unseen is providing the extra gravity needed to keep the system intact. This invisible structure forms what is known as a dark matter halo, a massive, spherical region surrounding the visible galaxy, extending far beyond the spiral arms, far beyond what telescopes can clearly map. So even when you look at the night sky and see what appears to be a dense field of stars, you are only seeing a fraction of what is actually there.
Most of the galaxy is hidden, not because it is far away, but because it does not interact with light in a way we can perceive. And yet, it is constantly influencing motion, shaping paths, determining how stars move, how galaxies rotate, how structures form and evolve over billions of years. While all of this unfolds, individual stars are living out their own life cycles. Some are young, burning hot and bright, formed relatively recently from collapsing clouds of gas. Others are ancient, cooling, expanding, or nearing the final stages of their existence. In certain regions of the Milky Way, particularly within spiral arms, New stars are still being created. Massive clouds of hydrogen gas collapse under gravity, forming dense cores that heat up over time. Eventually, pressure and temperature become high enough for nuclear fusion to begin. A new star is born. This process does not happen quickly. It unfolds over millions of years, quietly, gradually, without any sudden announcement. And at the same time, elsewhere in the galaxy, stars are ending. Some expand into red giants, shedding their outer layers into space. Others collapse into white dwarfs, slowly cooling over billions of years. The most massive stars end their lives in supernova explosions, releasing enormous amounts of energy and scattering heavy elements across the surrounding space. Those elements, carbon, oxygen, iron, become part of future stars, future planets, future systems, even future life. Which means the materials that make up your body were once inside stars, formed in events that took place long before the Earth existed. And even now, that cycle continues. Creation and destruction balanced across the galaxy. Not in a dramatic way, not in a way that can be heard or felt from here, but in a steady, ongoing process that never fully stops. At the very center of the Milky Way, something even more extreme exists. A region of intense gravity, where stars move faster, where space itself is curved more strongly. There, at the core, is a supermassive black hole, known as Sagittarius A star. Its mass is about 4 million times that of the Sun. It does not pull everything in at once. It does not consume the galaxy. It simply sits at the center, influencing the motion of stars around it. Stars orbit this central region, some moving at incredible speeds, completing orbits in just a few decades. Compared to the Sun's 225 million-year journey, this is extremely fast.
While you rest, the Milky Way continues exactly as it always has. Layered motion, invisible forces, slow transformations, all unfolding across a scale so vast that it quietly surrounds every moment of your life. And this is only a small part of it, because even within this single galaxy, there are regions we have not yet looked at closely. Places where motion becomes more subtle, more isolated, and in some ways, even more quiet. Further from dense star fields, further from bright structures, closer to the spaces in between. And that is the next part of this journey. Away from the brighter regions of the Milky Way, far from the dense spiral arms filled with stars and glowing clouds, there are places where the galaxy becomes noticeably quieter. Not empty, but quieter. The distance between stars begins to stretch, light becomes less frequent, and the structure that once felt crowded starts to open. This is interstellar space, the space between stars. Even within the spiral arms, stars are not close together. If the Sun were reduced to the size of a small grain of sand, the nearest star would still be several kilometers away. That is how much empty space exists between them. But outside the arms, in regions of lower density, that distance increases even further. Stars become scattered, sometimes separated by tens of light years. In these regions, there are no bright clusters, no glowing nebulae filling the sky, only isolated points of light, spread thinly across a vast darkness. And yet, this space is not completely empty. There are still particles here, extremely sparse but present. Atoms of hydrogen, traces of helium, occasional dust grains drifting without direction. So few in number that in a volume the size of a cube spanning several kilometers, there might be only a handful of particles. Compared to anything on Earth, this is close to a perfect vacuum. But over galactic scales, even this thin distribution matters, because gravity still acts here, slowly, subtly, pulling on everything, even across enormous distances. Within these quieter regions, there are stars that no longer belong to any cluster or dense structure. Some were formed in isolation, others were ejected. Gravitational interactions can accelerate stars to high speeds, pushing them out of their original systems. These are sometimes called rogue stars, not bound to a specific region, not part of any visible grouping, moving alone through the galaxy. If a planetary system remains attached to such a star, those planets travel with it, drifting through the Milky Way, far from the crowded environments where most stars are found. There are also rogue planets, objects that were once part of stable systems but were thrown out. Now they move independently, without a star to orbit, cold, dark, invisible unless detected indirectly. Some estimates suggest there may be billions of them, wandering through interstellar space, unlit, unobserved, and yet still part of the galaxy's motion. In these regions, time begins to feel different, not because it actually changes, but because there are fewer reference points, fewer nearby stars, less variation, less activity that can be easily seen. If you were located here, far from any dense structure, the sky would look very different. The Milky Way band would fade, the brightness of the night would diminish, stars would appear more isolated, more distant, and the sense of depth would increase. Distances that were already difficult to imagine would become even harder to grasp, because without nearby points of comparison, everything feels farther away. Light would still arrive, but less frequently and from fewer directions. In some areas, there would be long stretches of darkness with only a few distant stars visible at all. Yet even here, motion continues. Stars still move along their galactic orbits. Rogue planets continue their paths. Gas and dust drift slowly under the influence of gravity. And over very long timescales, these regions can change. Small fluctuations in density can begin to grow. A slightly denser patch of gas may attract more material, gradually increasing in mass, until eventually it becomes dense enough to begin collapsing. And in time, a new star may form, even in a region that once appeared empty. This process is rare in low-density areas, but not impossible, which means even the quietest parts of the galaxy are not inactive. They are simply slower, less visible, less dramatic, but still part of the same continuous system. If you could observe the Milky Way over billions of years, these regions would not remain unchanged. Stars would pass through them. Some would be captured into new structures, others would leave. The galaxy is not static. It evolves, gradually, continuously, even in its most silent areas. There are also regions filled with diffuse gas spread so thinly that they emit almost no light. These clouds can extend across vast distances, invisible unless detected by radio telescopes or other instruments. They do not glow like nebulae, they do not stand out, but they are present, and they contribute to the overall mass and structure of the galaxy. Occasionally, shock waves from distant supernovae or gravitational disturbances can pass through these regions, compressing the gas slightly, altering its motion. But these changes happen slowly, over time frames that are difficult to perceive directly. From within such a region, there would be no sense of urgency, no sudden shifts, only gradual change and a persistent quiet. The kind of quiet that does not come from silence alone, but from distance, from separation, from the absence of nearby activity. Yet even this is only one layer of the galaxy, because beyond these sparse regions, there are areas where matter begins to gather again, where gas becomes more concentrated, where light starts to return, where the conditions allow for structure to form once more. Gradients within the galaxy, from dense to sparse, from active to quiet, and back again, a continuous variation rather than a sharp boundary. And as you move through these transitions, the character of the Milky Way changes with you, not suddenly, but gradually, almost imperceptibly. Which means that even within a single galaxy, there is no single condition, no single environment, only a range, from dense regions filled with light to vast stretches where almost nothing seems to happen, and all of it connected, all of it in motion, even now, even while everything around you feels completely still. Because the galaxy does not divide itself into separate parts. It flows from one region into another, from density into emptiness, and back again, without interruption, without pause. And beyond these quieter regions, beyond the scattered stars and drifting matter, there are places where the structure of the galaxy itself begins to thin out, where the disk fades and something much larger and less visible begins to take over. As the scattered stars become fewer, and the thin gas between them stretches even further apart, the familiar structure of the Milky Way begins to change. The flat, disk-like shape of the galaxy, the region where most of its stars, dust, and visible light are concentrated, does not extend forever. It has limits. Not sharp edges, but gradual ones. A slow fading, a thinning of structure. If you could move away from the galactic plane, rising above it, or descending below it, the dense band of stars would begin to dissolve. The bright, cloudy appearance of the Milky Way would fade, replaced by a darker, more open view. From this perspective, the galaxy no longer looks like a glowing river of light across the sky. It becomes something else, a distant structure, a flattened disk, surrounded by a vast, nearly invisible region. This is where the galactic halo begins. The halo is not dense, it is not bright, it does not resemble the structured spiral arms below. Instead, it is a diffuse, extended region, stretching far beyond the visible boundaries of the galaxy. And yet, there are still patterns hidden within this space. Clusters, groups of stars bound tightly together, moving as a single unit. These are globular clusters, spherical collections of hundreds of thousands, sometimes millions of stars, packed into relatively small regions. They orbit the galaxy, not within the disk, but around it, above, below, passing through regions where the density of stars is otherwise extremely low. Some of these clusters are incredibly old, formed more than 10 billion years ago, long before the Sun existed, long before the Milky Way took on its current spiral structure. Their stars are different, often lower in heavy elements, because they formed when the universe itself was younger and less enriched by previous generations of stars. If you were near one of these clusters, the sky would look very different. Instead of scattered, distant points of light, you would see a dense sphere of stars, bright and closely packed, thousands visible at once. A concentration of light, suspended in an otherwise dark and open region. And beyond these clusters, beyond even the faint stars of the halo, there is something else, something that does not appear in the sky at all. The dark matter halo. It extends far beyond the visible galaxy, much larger than the disk, much larger than the regions where stars can be easily detected. It forms a massive, roughly spherical structure surrounding everything you have imagined so far. And yet, it cannot be seen, not directly. There is no glow, no reflection, no image you can form of it with your eyes. Its presence is known only through its effects, through the way stars move, through the way galaxies rotate, through gravitational influence. If the Milky Way contained only the matter we can see, its outer stars would not remain bound. They would move too quickly and escape, but they don't. Their motion stays consistent. Their paths remain stable, which means something else is holding them in place, providing the additional gravity needed to maintain the structure. That something is dark matter. It outweighs all the visible matter in the galaxy. Stars, planets, gas, dust, all of it combined makes up only a small fraction of the total mass. The rest exists in this invisible halo, extending far beyond the edges of light. And even here, in this vast, quiet region, motion continues.
Stars in the halo orbit the galaxy in long, extended paths. Globular clusters trace slow arcs through space, and the entire structure, disk, halo, dark matter, moves together as part of something larger. Because the Milky Way is not isolated. It is part of a group, a collection of galaxies bound by gravity, known as the local group. And within this group, the Milky Way itself is in motion, not drifting aimlessly, but following a path shaped by the gravitational pull of neighboring galaxies. The most significant of these is the Andromeda galaxy, larger than the Milky Way, located about 2.5 million light-years away, and slowly, very slowly, moving closer. The speed of this approach is not something you would notice, not tonight, not in any single moment, but over millions of years it becomes measurable, over billions, inevitable. The two galaxies are on a path that will eventually bring them together, not as a collision in the way objects collide on Earth, but as a gradual merging. Their structures will overlap. Their stars will pass by one another. New patterns will form. New orbits will emerge. But all of that lies far in the future. For now, the motion is gentle, steady, almost unnoticeable. And from within the Milky Way, it does not feel like movement at all. Just as the rotation of the Earth feels still, just as the orbit around the Sun feels constant, just as the journey through the galaxy remains silent, everything continues, layer upon layer of motion, each one part of a larger system, from the smallest particle drifting through interstellar space to the vast halo extending beyond visible light, to the movement of entire galaxies within the local group, all of it connected, all of it unfolding at the same time, and none of it needing to rush, because the scale of these processes is far beyond anything measured in hours or days. Even 1,000,000 years is a brief moment in this context, and yet all of it is happening now, already in motion, already underway, without interruption, without pause. And as the structure of the Milky Way stretches outward, fading into regions where even stars become rare, the boundary between galaxy and the space beyond it begins to blur. There is no clear line where one ends and the other begins. Only a gradual transition from something structured to something even more open, even more quiet, even more distant. And that is where the next part of this journey continues, beyond the galaxy itself, into the vast space between galaxies.
And there are invisible structures that only reveal themselves through gravity. Because even in this vast openness, matter is not distributed randomly. On the largest scales, the universe forms a kind of structure, a pattern, not easily seen from within, but measurable when observed across enormous distances. Galaxies are not scattered evenly. They are arranged along filaments, long thread-like structures that stretch across space. Where these filaments intersect, galaxy clusters form, dense regions containing hundreds, sometimes thousands of galaxies. And between these filaments, there are voids, enormous regions where very few galaxies exist at all. Some of these voids span hundreds of millions of light years. Inside them, the universe becomes even quieter, even more sparse. If you were located within one of these voids, far from any galaxy, the sky would look almost completely dark. Not because there is nothing in the universe, but because everything is too far away to be seen clearly. Only the faintest points of light, barely distinguishable from the background, would remain. The Milky Way itself would no longer be visible as a bright structure, just another distant galaxy reduced to a small, dim shape. And yet, even here, motion continues. Galaxies drift along the filaments, pulled by gravity toward denser regions. Clusters slowly evolve as galaxies interact over time, and the universe itself is expanding, not into something, but within itself. Space is stretching. Distances between large structures are increasing. And this expansion is not slowing down, it is accelerating, driven by something we do not fully understand: dark energy, another invisible component of the universe, even more mysterious than dark matter. It does not pull, it pushes, causing the fabric of space to expand faster over time. Which means that over extremely long timescales, galaxies that are currently visible will drift so far away that their light will no longer reach us. The observable universe will shrink, not because it is getting smaller, but because distant regions are moving beyond the reach of light. And yet, none of this is noticeable in a single moment, not in an hour, not in a lifetime. Everything unfolds slowly, on timescales so vast that change becomes almost impossible to perceive directly. Which is why, from where you are now, everything feels still. The night sky appears fixed, unchanging, silent. But that stillness is only a matter of perspective, because across these immense distances, motion never stops. It only becomes harder to see, harder to measure, harder to imagine. And yet, it is always there. From the rotation of a single star, to the drift of entire galaxies, to the expansion of space itself. All of it happening at once. All of it part of a single continuous system, and all of it unfolding without any need for attention, without any sound, without any signal that demands to be noticed. Just quiet motion on a scale that surrounds everything. And within all of this, within this vast network of galaxies, filaments, and voids, there is one small region, one ordinary spiral galaxy moving along its path, the Milky Way, carrying its stars, its planets, its quiet nights forward through this expanding space. And within that galaxy, on a small planet orbiting an average star, there is this moment, still, calm, unaware of the immense structure that surrounds it, but always connected to it. Because no matter how far outward you go, no matter how large the scale becomes, it all leads back. From the largest structures in the universe to the smallest details of a single world, everything exists within the same continuous reality, and everything moves together, even now, even in complete silence, even while it feels like nothing is happening at all. And as these larger scales begin to fade from focus, as distances stretch beyond what can be easily imagined, attention can slowly return, not to stillness, but to the smaller layers of motion that continue much closer, much more quietly, within the galaxy itself.
As the scale begins to narrow again, the vast distances between galaxies slowly recede from focus. The enormous structures, the filaments, the voids, the expansion of space, all remain exactly as they are. But attention shifts back towards something closer, more detailed, more intricate. Because within a single galaxy, within even a single region of that galaxy, there are systems just as complex, just as active, only operating on smaller scales. The Milky Way is not only a collection of stars, it is a collection of systems. Each star surrounded by its own environment, its own balance of gravity, motion, and time. Some stars exist alone. Others are part of binary or even triple systems, orbiting one another in carefully balanced paths. In these systems, motion becomes more immediate, more visible. Stars circling each other over years, decades, or centuries. Distances measured not in thousands of light years, but in fractions of a single one. And beyond many of these stars, there are planets, worlds of different sizes, different compositions, different histories. Some orbit close to their stars, moving quickly, completing a full orbit in just a few days. Others travel much farther out, taking decades or centuries to circle once. Each orbit shaped by gravity, each path stable, but never perfectly still.
Within even a single planetary system, motion is layered. A planet rotates on its axis, creating cycles of light and dark. At the same time, it orbits its star. And beyond that, the entire system moves through the galaxy. Everything nested, everything connected. If you were to observe such a system from a distance, you would see a constant flowing pattern. Planets tracing paths around their star, moons orbiting those planets, rings of dust and debris slowly shifting over time. And between these larger objects, there are countless smaller ones. Asteroids, comets, fragments left over from the formation of the system. Some following stable paths, others moving on long, stretched orbits, returning only after thousands of years. Occasionally, interactions occur. A gravitational pull slightly alters a trajectory. A close pass changes the path of a smaller object. Over long periods of time, these small changes accumulate, reshaping the system, but not suddenly, not violently. In most cases, the changes are gradual, subtle, almost invisible in the moment. Within these systems, light plays a different role. It is no longer traveling across millions of light years. It moves across much shorter distances, minutes, hours, sometimes days. Light from a star reaches its planets, warming them, illuminating them, creating environments where chemistry can take place, where atmospheres can form, where, in some cases, conditions may allow for life. And just as with stars, planetary systems also evolve. Early in their formation, they are chaotic, filled with debris, frequent collisions. Gradually, over millions of years, they settle. Orbits stabilize. Most of the remaining material is either absorbed or ejected, leaving behind a more ordered system. But even then, it is never completely fixed. There are always small movements, tiny variations, minute shifts in gravitational balance. And all of this is happening not in isolation, but as part of the larger motion of the galaxy. Each system carried along, orbiting the galactic center, passing through different regions over time. Sometimes moving through denser areas where nearby stars are more common, sometimes drifting through quieter regions where distances between systems grow larger. If two stars pass relatively close to one another, their gravitational influence can have effects. Not dramatic ones, not collisions, but subtle disturbances. Outer objects, like distant comets, may be nudged, their paths slightly altered, sending them inward or pushing them farther out. These interactions are rare, but over billions of years, they contribute to the slow evolution of systems. And beyond the visible objects, there are still influences that cannot be seen directly. Magnetic fields, radiation, winds of charged particles flowing outward from stars.
All of these shape the environments around them, determining how matter moves, how atmospheres behave, how energy is distributed. Within a single planetary system, there is already a complex balance of forces. But when you consider that there are billions of such systems spread across the Milky Way, each one slightly different, each one following its own path, the scale of that complexity becomes difficult to fully grasp. And yet, all of it continues, quietly, without interruption, without drawing attention to itself. Because, Unlike events that happen on Earth, these processes do not demand to be noticed. They do not create sound. They do not signal urgency. They simply unfold, step by step, moment by moment, across timescales that extend far beyond a single lifetime. And even now, in this moment, there are systems forming, others stabilizing, others slowly changing in ways that will only become visible far in the future. All of them moving, all of them part of the same larger structure, carried along within the Milky Way as it continues its own motion through space. And within that vast collection of systems, there are still layers we have not looked at closely. Processes that operate even more quietly, even more gradually, at scales so small or so extended in time that they are almost impossible to perceive directly. And that is where the focus begins to shift next, toward the subtle changes, the slow transformations that continue even when nothing seems to be happening at all. Time at this scale does not move the way it feels. It does not pass in hours, or days, or even years. Those are measurements tied to a single planet orbiting a single star. But beyond that, time stretches. It expands into something far less immediate, something that cannot be easily noticed, only understood. Because in the Milky Way, change is not absent, it is simply slow. So slow that it disappears within a human lifetime. Stars do not suddenly appear. They do not suddenly vanish. Galaxies do not shift in ways that can be seen from one night to the next. And yet, given enough time, everything changes. The spiral arms themselves are not permanent structures. They shift, reform, fade, and re-emerge in slightly different shapes, not quickly, but over hundreds of millions of years. Stars that are now part of one region will eventually drift into another. The Sun itself is not fixed within the Orion arm. It is passing through it, and over tens of millions of years it will move beyond it, entering a slightly different region of the galaxy, with different densities, different nearby stars, different surroundings. The night sky, as it appears now, is not permanent. The constellations, the patterns that feel familiar, are temporary alignments. Stars that appear close together are often separated by vast distances. They only look connected from this specific point in space. As time passes, those alignments slowly change. Stars move on their own paths, and over tens of thousands of years, the shapes begin to shift. Over hundreds of thousands, they become unrecognizable. Over millions, entirely new patterns emerge. Which means the sky you see tonight is only one version of something that is constantly evolving. And beyond the motion of stars, there is the evolution of the stars themselves. Every star is in a state of change. From the moment it forms, it begins a long process of transformation. For most of its life, a star remains relatively stable, fusing hydrogen into helium, producing light and heat, maintaining a balance between gravity pulling inward and energy pushing outward. But this balance does not last forever. Eventually, the fuel begins to run low. The core changes. The structure shifts. For stars like the Sun, this leads to expansion, becoming a red giant, its outer layers expanding outward, enveloping nearby space. After that, those outer layers are released, forming a faint, expanding cloud. and what remains is a dense core, a white dwarf, cooling slowly over billions of years. Other stars, more massive ones, follow different paths.
Their life cycles are shorter, their endings more energetic. Supernova explosions, neutron stars, black holes. Each outcome dependent on the mass and composition of the original star. And all of these processes are happening continuously across the galaxy. Not in one place, not at one time, but spread out, distributed. So that at any given moment, some stars are forming, others are evolving, others are ending. A constant cycle, but one that does not repeat in exactly the same way, because with each generation of stars, the composition of the galaxy changes. Early in the universe, there were almost no heavy elements, mostly hydrogen and helium. But as stars lived and died, they produced heavier elements, carbon, oxygen, iron, and released them into space. Which means that newer stars form from material that is different, more complex than what existed before. And over billions of years, this gradual enrichment continues, changing the types of planets that can form, changing the chemistry of entire systems, even influencing the potential for life. All of this unfolding slowly, layer by layer, without any single moment where everything changes. Instead, a continuous progression, small differences accumulating over time, leading to outcomes that are only visible when viewed across vast spans of time. And beyond stars, even the structure of the galaxy evolves. Interactions with smaller galaxies, gravitational influences from nearby systems, subtle shifts in mass distribution, all contribute to long-term change. The Milky Way has absorbed smaller galaxies in the past, and it will continue to do so. Not as sudden events, but as gradual integrations. Stars from those galaxies becoming part of the halo, their motion blending into the larger system. Traces of these events remain, streams of stars moving together, evidence of past interactions. And all of this contributes to the slow reshaping of the galaxy. At the same time, the overall motion of the universe continues. Galaxies drift, distances expand, large-scale structures evolve. And the future of all of this is not fixed. There are multiple possibilities. Some suggest continued expansion, leading to a universe where galaxies become isolated, too far apart to interact, too distant for light to travel between them. Others consider different long-term outcomes, but all of them unfold over timescales so large that they exist far beyond immediate experience. Which means, in this moment, nothing feels like it is changing. The sky appears stable, the stars appear fixed, the galaxy appears constant. But that is only because the processes that shape it move at a pace that cannot be seen directly. They require time. Not minutes, not years, but millions, billions. And within that span, everything shifts, everything evolves, everything moves forward without ever needing to rush. And even now, as all of this continues, there are processes happening at scales even more subtle, changes so gradual that they exist almost entirely beyond perception, not just in space, but in the passage of time itself. And that is where the focus begins to settle next, on the quietest kind of change, the kind that happens even when nothing appears to move at all. There are changes that happen slowly. And then there are changes that happen so slowly, they almost seem like they don't happen at all. Not because they are absent, but because they exist on timescales that stretch far beyond anything that can be directly experienced. These are the quietest processes in the universe. Not dramatic, not sudden, but constant. Always moving forward, even when everything appears completely still. One of these processes is the gradual loss of energy. Not in the sense of something suddenly stopping, but in the slow redistribution of energy over time, a process often described as entropy. It does not move in a direction you can see. It does not have a visible shape, but it defines how systems evolve. Over time, energy spreads out. Differences become less pronounced. Hot regions cool. Dense structures become more diffuse. Motion remains, but becomes less concentrated, less intense. In the context of stars, this means that even after their active lives end, their remnants continue to change. White dwarfs, the dense cores left behind by stars like the Sun, do not disappear. They remain, but cool, slowly, radiating away their remaining heat over billions, trillions of years. Eventually, they become what are sometimes called black dwarfs, cold, dark, no longer emitting visible light, but still present, still part of the galaxy. Neutron stars, incredibly dense remnants of massive stars, also change over time. Their rotation slows, their energy output decreases. Gradually, they become quieter, less active. Black holes, often thought of as final states, are not entirely static either. Over extremely long periods, they can lose energy through a process known as Hawking radiation, a process so slow that for large black holes, it would take far longer than the current age of the universe for any noticeable change to occur. And yet, even they are not completely unchanging.
But without new energy being introduced in the same way, the overall system becomes more uniform, less structured, more evenly distributed. This is sometimes described as a kind of equilibrium, not a complete stillness, but a state where differences are minimal, where there are no strong gradients, no intense sources of energy, just a quiet balance spread across an immense scale. And all of this, all of these slow transformations are already part of the universe's trajectory, not something separate, not something distant in a conceptual sense, but a continuation of the same processes that are happening now. Right now, stars are forming, stars are ending, galaxies are moving, energies being redistributed, and over time, these processes lead forward, step by step, into these quieter states. But from where you are, in this moment, none of it feels immediate. None of it interrupts the stillness of the night, because the scale is too large, the pace too slow, and the changes too gradual. Which means, for now, everything remains exactly as it appears. A quiet sky, a stable world, a sense of stillness, even though beneath that stillness, everything continues, always in motion, always changing, just at a pace that does not need to be noticed. And in that way, the universe does not demand attention. It does not require awareness. It simply unfolds, layer by layer, moment by moment, across scales both vast and subtle. And even now, as all of this continues far beyond perception, there is still one final way to understand it. Not through distance, not through time, but through the simple fact that all of these layers, from the largest structures to the smallest changes, are happening at once, surrounding everything, including this moment, including you. Not separate, not distant, but part of the same continuous motion that never fully stops. All of it, from the slow rotation of a single planet to the motion of stars across a galaxy, to the quiet expansion of space itself, continues at the same time, layered, connected, uninterrupted. And yet, from where you are, none of it feels overwhelming, none of it feels urgent, because here, in this moment, everything is calm. The surface beneath you is still. The air around you is quiet. The world feels at rest. And in a way, it is. Not because motion has stopped, but because it has become steady, balanced, predictable. The kind of motion that no longer demands attention, the kind that allows everything else to slow down. Because even though you are moving, even though you are part of all of this, there is nothing you need to follow, nothing you need to keep track of, no system you need to understand completely. All of it continues, with or without awareness. Stars will keep forming, others will fade. The galaxy will keep turning. The universe will keep expanding. And all of it will happen exactly as it always has, quietly, without interruption, without asking anything from you. And here, on this small planet, in this brief moment, you are allowed to be still, not separate from everything else, but not responsible for it either. Just present, just here. Because the same forces that guide the motion of galaxies also allow for stillness. The same structure that keeps everything moving also creates moments like this one, stable, calm, undisturbed. And even though, beyond this moment, there are distances that cannot be crossed, timescales that cannot be fully understood, and processes that continue endlessly, none of it needs to be held on to, none of it needs to be carried, because it will continue on its own, exactly as it always has. So there is nothing to follow now, nothing to imagine further, nothing to reach toward, only the quiet understanding that everything is already in motion, already unfolding, already complete in this moment. And within that, there is space to rest. The galaxy continues, the universe continues, and this moment remains exactly as it is, still, calm, and undisturbed.